This is Gail Kovac with Gresham Barlow School District, Summer School, High School Credit Recovery, Data Reasoning and Learning Target number 7. I can describe a distribution by shape, outliers, center, and spread. We can use that way to describe any kind of distribution, whether it's a dot plot or a histogram or a box plot, whatever it is. So in this first example, I've got a histogram. And I don't really know what the data is about. It's a little bit more generalized data than a dot plot would be, but I'm going to describe what I see. Let's start with the shape. So with shape, there's typically a few different ways that we can see the shape of a graph. One that is symmetrical, which tapers at the bottom, comes up to a peak, and then tapers back down. That's called approximately normal, or a normal curve. One, however, that has skew, S-K-E-W, is one that is kind of tilted one way or the other. So if a data has a lot more lower data on one side and then it has a big bump on the other, we call this one skewed to the left because there's a tail on the left. It looks like it's been stretched out or pulled to the left. If, on the other hand, we have a distribution where it's very heavy on one side and then pulls this way towards the right, we call this skewed to the right instead. So let's take a look at the shape of this distribution. It looks like I've got a little bit of data on the left. I have most of the data in the middle, and then I've got a little tapering over here on the right as well. Now, it's not perfect, but it's approximately normal. So I'm going to call this a approximately normal distribution. So we're not going to say that it is a normal distribution because that would mean it's perfect, and we're really not going to find any distribution that's perfect this way. So we're going to call this one approximately normal. And normal is with a capital N because it doesn't mean your layman's term normal like, oh, it's just typical or regular or acceptable. It's normal with a capital M, that statistical word normal, which means the shape of the distribution is this way. All right, next we have outliers, and outliers are values that are far away from the big clump of data. It's a value that is unusually large or unusually small compared to where everything else ended up. And in this case, I don't see any gaps in the data with one way off to the side. So I might have like an outlier if this number line continued, if I had a big gap here and then I had just like a value of 1 over here. If I had this, then I would say, yeah, that's a weird point. That one is an outlier. It is unusual. It is not common. But in this case, all of my data is clumped together and I don't have any big gaps with kind of one far off on the left, one far off on the right. So we have no outliers or unusual points here. So there are no outliers. All right, now I'm going to go to, so that was outliers and we did shape. So now let's go to center. And for center, we are looking for either mean, median, mode, something like that. So it's one of your averages, basically. So where's the middle of the distribution? Now you might be tempted to look at the number line at the bottom and say, oh, this one's in the middle. We're not talking about the middle of the number line at the bottom. We're talking about the middle of the data set. So we have to figure out where would the median value fall? Where's the 1 in the middle? So let's see here. This bar between 60 and 65, this is a histogram, remember, so these bars bump up against each other, and each of my bars represents a range of possible values. There are 3 that are within the range of 60 to 65. There's 3 also that are between 65 to 70. 70, 75, there's actually 8 values here. There's 10 values within this range. There are, is that a 5? Yeah, there's 5 here, and there's just 2 right here. So if you could imagine that these are, they're actually like dots in here instead, right? You have to figure out, well, where would the middle dot be, right? 8 dots here, 10 dots here, just 2 here. Where would the middle dot be? So let's see here. All right, well, I think it's probably going to be in this tall bar right here, but let's see. If I were to cut it like this, I would have 10, 11, 12, 13, 14, 15. I would have 17 on this side, and I would have 8, 9, 10, 11, 12, 13, and I'd have 14 on that side. That's almost in half, but half is going to be somewhere in here. So somewhere within this range of 75 to 80, that's where half of my data, my middle point, my median lies. So I don't know exactly the value of it because this is generalized data. I just know it's somewhere between 75 and 80. So my center is going to be a median. Median is going to be somewhere between 75 and 80. Median 75 to 80. And you know what? My mode is going to be there as well. Well, no, I don't know for sure where my mode is. Median is the best one to look for. Now, we can't find the mean average because that requires you to know exactly all of the data values. And this is more generalized data, so I don't know exactly where that is. So we're going to just go with median if it's for a histogram or a box plot that you'll see. If you give an actual dot plot, then you can find the mean average, but honestly, median, your middle value, that's going to be good for your center. And last one we've got now is spread. It's how is the data spread out? And for spread, the best one to figure out oftentimes is your range. It's what is the distance from the top to the bottom value from the minimum to the maximum. And in this case, it looks like we go from 60 to 90 potentially. Now, I don't know what my actual minimum is. I just know that it's somewhere between 60 and 65. So maybe it's 65, not 60. And maybe my maximum is at 86 and not 90. I don't know. But my range goes from 60 to 90, and those are 30 apart. So my spread is going to be 90 take away 60, which is a range of 30. So it's a 30 range. And I'm just going to draw my normal curve on there again, just so we kind of see everything here in one. All right. So that's shape, outlier, center, and spread for a histogram. Let's do it for this box plot here now. Box plot is even more generalized, less specific data. So let's start with the shape. So shape of a box plot, we've got those 3 shapes that we've talked about. That is approximately normal and skewed to the right and skewed to the left. So if it's approximately normal, you're going to see something like this, where it's very symmetrical, right? Like this. If you have a strong skew, then you might see a very long whisker. You're going to see a more compacted box, and you may or may not even see a whisker on this side, something like that. This is skewed to the left because you've got that tail pulling out to the left. Might even have some outliers out here, which would be kind of dots like this all by themselves. And then similarly, but opposite, if you had more data compacted over on this side and you had a super long tail pulling out here, maybe even with like an outlier or 2 out there perhaps, and you have a long tail on the right, then that would be skewed to the right. So let's take a look at our distribution here. Well, in this distribution, box is a decent size. This is the median here is pretty much in the middle of that box. It's not too far off. And the biggest takeaway here is that the whiskers here are pretty close to being the same. I do see a couple outliers right here, but they're not like way, way out. I would call this almost approximately normal. I mean, it's not going to be perfect, but it looks approximately normal to me as well. I don't have a super long tail on the left or right, so I'm going to call that one approximately normal as well. So we're going to go with this one here, and I'm going to again say approximately normal. All right. So next we're going to look at outliers, and I know I already talked about this a minute ago with those extra little points there. For a box and whisker plot, there's actually a way to calculate specifically using the interquartile range whether or not a data point is technically classified as an outlier or not. And if they are, then they use a modified box plot, which includes points as your, like these points right here, as your outliers. So in this case, we do, yes, we have 2 outliers. These are values that would be far off from the other data points. We have 2, and then you're going to mention where they are. So this one, if you look down, let's see here. Where is that? And where is this one? This one looks to be at about 70. This one is on the upper end between 60 and 70. I'm going to say maybe 66, 67, something like that. So you're going to have to guess a little bit more sometimes with these. So I'm going to say at 67 and 70, we've got 2 of them. So there's 2 outliers here. You may also have 1 or 2 on this side, or maybe just 1, or maybe none at all. If you saw none of these extra points, then there would be no outliers. All right, we're going to go with the center here. And again, since this is very generalized data, there's no way we can actually calculate the mean average here because, I mean, I don't know any of the specific numbers that went into this box plot. So we're going to find our center as just the median, which is this one right here. Now, again, you're not finding the center of the number line. You're not going to say it's this value because that's halfway between 0 and 80. That's not what we're asking for. We're asking for not the middle of the number line, the middle of the distribution. So your median here, that's what you're looking for, is that line that goes down the middle of the box, not the number line. So the center, the median, is at 30. And last one, we are going to look at the spread. And with a box plot, there's a couple different ways we can explain spread. We'll start first with range, which we've done before. It looks like my maximum here is at 70. Again, not the top of the number line. Where's the top of the data? At 70. And my lowest one is somewhere like around here. Let's see where you guys might think that is. Like right around here. I don't want to say it's quite 5. It might be less than that. I'm just going to go ahead and say 5. I think that's about halfway in between 0 and 10 there. So my spread, my minimum and my maximum goes from 5 to 70. So I'm going to do 70, take away 5 to find that distance in between there. So I've got a spread of 65 for range. And the other one that I can also find is the range of the box, from here to here. So from here to here, I want to know how far that is. That goes from 20 to 50. So we're going to call that your IQR. That's your interquartile range right here. And it's the distance of the box. So your IQR goes from 50 or 20 to 50. So let's find the distance there. 50 minus 20 is 30, which means my IQR is 30. That's where the middle half of the data is. So 50%, the middle 50% of the data is 30 apart. Let's see here. So we've got the shape as approximately normal. I think I'll draw this over here to just show how this is. Pretty symmetrical. We have a couple outliers. Median is what we're going to be finding for both of these. If you do actually have the dot plot, then you can find the mean as well, but don't bother with that. Finding just the center point median is probably your best bet. So don't forget shape If it is skewed, and let me just actually write this here on the side. So this would be skewed to the left. This would be skewed to the right. I'm going to write skew here. And for a box plot, that's going to look skewed to the left like this, skewed to the left, or skewed to the right like this. So then you've got examples of each right here. Here's skew. So shape, outliers, center, and spread is the way you can describe any univariate quantitative data set.